Hey guys, let's look at computing paired difference tests. These will be cases where probably one of the more popular ones is using medicine or weight loss, where you are measuring something at one point in time, measuring it again at a later point in time, comparing the differences, but they're paired together because it's one person or thing being measured in two different points of time. For example, this problem, and this is in your 8.4 paired difference, testing paired differences homework link. The first problem is fishing better from a boat or from the shore. Pyramid Lake is located on the, I don't know how to pronounce that, Indian Reservation in Nevada. Presidents, movie stars, and people who just want to catch fish go to Pyramid Lake for really large cutthroat trout. Let row B represent hours per fish caught fishing from the shore, and let row A represent hours of fish caught using a boat. The following data are paired by month from October through April. Okay, so October, we have. Now, you just got to be really careful how you put this in your calculator. What I would recommend is you go Stat, Edit. If you have data there, go up to the top of the column, Clear, Enter. It wipes out the entire column of data. And instead of deleting them one at a time, you can just do a mass delete. Um, it's up to you how you put this in because I have to be very organized in order to get a problem right. I'm going to put A for boat in L1. That way it'll be A, and then L2 will catch the B values, 1.4. And again, this is row A for boat. You can do it any order you like. You just got to be careful when you do it. Okay, so L2, I'm going to do row B, which is shore. Okay. Give your numbers a quick glance. Make sure you got them all in there. I don't think I made any glaring errors. Never know. Okay, now back to the problem. Using a 1% level of significance to test if there's a difference in the in the population mean hours per fish caught using a boat compared with fishing from the shore, they are defining the difference as B minus A. B minus A. In L3, go to the top of the column. In order to calculate B minus A, the way I put them in, it's going to be L2 minus L1. At the bottom of your calculator for L3, you can tell it that you want, and again, this is why L3 is highlighted, that I want to do column 2 minus column 1. And then it will populate L3 with the differences in all those values. State the null and alternative hypotheses. Because they're saying no difference, this problem didn't commit to greater than or less than. They just want to say, is there a difference? You're going to pick the one where you have equal and not equal, two-tailed. Difference just means not the same. We are told that the data up here at the top assume that the distribution of differences is approximately normal. There's a lot of extra stuff in there if you want to read through it when you're doing yours. We're going to use the student's t because we're told that the differences are normally distributed. So that's the one we select for the sampling distribution. We don't know the population deviation, so these top two, the top and the bottom are out. That would be using a z test. All right, I'm going to go over here to the calculator, second mode, and I'm going to quit the value of the sample statistic. Now, since we're concentrating on the differences and not boat versus shore, we're looking at the differences of those two. We're going to go to Stat, go over to Tests, Z-Test. Since we have typed in data, if the summary stats weren't given, we've actually had to type it in. Toggle over to Data, hit Enter. We were asked to compare difference versus not different, so 0. Whoops, I had a lag. We're going to put 0 there. We want it to read the third column, so we're going to need to change L1 to L3, second 3. That'll do it. Go down here. Our alternative hypothesis was not equal to 0. That's fine. Calculate. Okay, so our T statistic rounded to 3 decimal places is 2.153. 2.153. Our p-value, which is the probability of making a type 1 error, is 0.07. That fits between 0.05 and 0.10. So that's the correct range for your p-value. Remember, our significance level alpha was 0.01. That's greater than alpha, so we're not going to reject the null. Let's see. And then also on this graph, because of difference where you have a two-tailed test, you will have shading on each end, each side. Okay, let me put this down. Based on your answers in parts A to C, will you reject or fail reject the null hypothesis? P was greater than alpha, so we fail to reject the null hypothesis and conclude the data are not statistically significant. Our conclusion is, when we fail to reject the null hypothesis, there is not enough evidence from that table to claim a difference in population mean hours per fish between boat fishing and shore fishing. So you could tell from the table the times weren't identical, but they're not statistically different either. So it would make no difference if a celebrity fished from a boat or ashore. Okay, and then number 2 is just a repeat. We have 5 weather stations on Trail Ridge Road in Rocky Mountain National Park. The peak wind gust in miles per hour for January and April are recorded below. Does this information indicate that the peak wind gusts are higher in January than in April? D is defined as January minus April. Significance level, that's alpha. Again, that's 0.01. And most of your social sciences, those are going to be 0.05 or 0.10, maybe even in an educational setting too. Okay, let's go to Stat, Edit. We're going to clear these columns out. Remember, highlight the column, clear, enter. You can do them one at a time. It's probably just as fast to do them one at a time. There is a mass erase or clear feature. Okay, January, I'm going to put in the top row, 139. Okay, so every value from January, I'm going to put in L1. Every value from April. Okay, now again, difference is defined as January minus April. So that's this time it's going to be L1 minus L2. L1 minus L2. January minus April. Okay, I'm going to pan up. Approximately normal, so I'm sure we're going to have the same assumptions as the problem we did just above. Wind gusts are higher in January than in April. Let's think about that. If January is more than April, when you subtract a high number minus a lower number, your result will be positive. For example, 7 minus 1 is a positive 6. 10 minus 3 is a positive 7. So we're going to expect the difference to be greater than 0 based on how it's defined. So the null hypothesis is no difference between the months. The alternative is we're claiming that the wind gusts are higher in January than in April. Okay, what sampling distribution will you use? Excuse me. I'm going to go ahead, because up here, approximately normal, I'm going to select the same one from what we did in the first problem. Students T, we assume that D has approximately normal distribution. And hopefully I didn't misread it. So let's go through the same motions. I'm going to second mode to quit. Stat, test, t-test. We still need to use data because we manually entered data. The null hypothesis is 0. We're going to leave it there. We're going to have it read the third column. That's the one containing the differences. Greater than 0, we're going to have to switch our alternative to a right-tailed. And then we can calculate. Our t value is 1.280. 1.280. Our p-value is 0.135. 0.135. I believe it'll fit in that range. Right-tailed, you only have shading on the right side. So this top left graph is the 1. Okay, now let's remember. Actually, let me just go up here. Oh, don't do that. Here we go. Okay, our p-value is 0.135 if you round to 3 places, which is definitely larger than alpha being a 0.01. If p is greater than alpha, do not reject the null. You do not have enough evidence. And then part E is going to match the same thing. Fail to reject the null, not enough evidence to claim that the wind gusts are higher in January than they are in April. So I'm going to submit. Cross your fingers. Look for all green check marks. We've got them. Whoop, we didn't have them. What did I do? Oh, I just picked the wrong radio button. P's greater than alpha. Fail to reject the null. I had it down here right. I just didn't have it up here. Let me resubmit that. And then we'll have a clean sweep on green check marks. There we go. I hope this helps.